Good afternoon, everybody. My name is Trevor Whalen, and I'm a senior ocean engineering student here at the University of Southern Mississippi. Today, I'll be talking to you guys about my senior project, which is titled Establishing a LoRaWAN Gateway at the University of Southern Mississippi. I want to preface this. Okay, it's working. Cool. So originally for this project, the original motivation was to build a system of environmental monitoring buoys. I wanted to build them for a developing country. Originally, I looked into countries such as Vietnam. I'm not saying they're an underdeveloped country or nothing like that. I'm just saying that they have a couple issues. For example, in their aquaculture. So there's a lot of shrimp farmers there, and they're not doing the best methods of keeping the environment safe in the ways that they're actually changing the pH values or adjusting their waters for the actual farming aspect. And this is causing a lot of damage to the environment. It's causing ecosystems to go extinct. It's causing a very just bad impact on everything around them. And so when I was looking into this, I realized I would need to make these buoys very cost effective, as well as very power efficient to even be useful in a developing country. And there's a lot of issues that are associated with that. And in a year's time frame, I would not have been able to solve all of them. So I really narrowed it down and focused more on just one aspect of it. And that is associated with its form of wireless communication. And I looked into LoRa to do this. So what is LoRa? LoRa stands for long range, and it is a form of wireless radio communication technology designed for long range, low power applications, and it's often seen in the IoT, which is the Internet of Things landscape. For those of you that may not know what IoT is, I'll explain later on, but if you do know what it is, good for you. So LoRa is in the same vein as Wi-Fi, Bluetooth, cellular. Now, Wi-Fi and Bluetooth have, let's say, a range of feet and meters, so about 30 to 60 feet or so. Cellular has more or less miles and kilometers. It's a much longer range. Now, LoRa is also in this longer range. LoRa can also be in the miles and kilometers. Aside from that, what really sets it apart from the rest is that it has a much lower bandwidth, aside from everything maybe just except for Bluetooth. Now, this lower bandwidth refers to the amount of data it's able to send per message, or just about. Cellular has a much higher bandwidth, and this means that you're able to stream like a movie or something, but this also comes with the cost of a much more battery draining effect. So to stream your movies, you have to spend a lot of power, as well as if you want long range, high bandwidth, and high bandwidth, long range, you're going to have to expend a lot of power. LoRa is a little bit different. This lower bandwidth allows for it to send small amounts of data, very long distances, while keeping the power consumption very minimal. The batteries of these devices can last up to years sometimes. So LoRa is really good for sending sensor readings. So say, for example, a temperature sensor, a GPS location, maybe a humidity sensor. And so it's also very cost effective. So if you were to use something like cellular, you'd have to pay a monthly fee of $50 to $100. And this can definitely get higher and higher as you add more devices. LoRa is a free open source technology. So you just have to buy a module such as this. These modules are about $15 off Amazon. You can get some cheaper ones as well. But that's all it really takes to get into using it. So I want to recap what I just said. LoRa has long range, low power, and is very cost effective, all while having a low bandwidth. If you need a higher bandwidth, LoRa is not your perfect solution. For me, it's perfectly ideal for working with these buoys or a similar technology. So I mentioned I talked about Internet of Things. So the Internet of Things refers to the network of interconnected devices that communicate via the internet. So this would be like your cell phone and your thermostat. It's the ability for you to raise and lower ability for you to basically connect to another device through the internet. And LoRa has kind of found its niche in this area, with it being used in smart agriculture, smart city solutions, and asset tracking. In smart agriculture, farmers are able to set it up to monitor humidity, soil moisture, as well as temperature, and be able to automate it to where it gets watered whenever these are low or if there's an issue. And for smart city solutions, it's used in several different ways. It's used to basically, you can use it to monitor sounds stupid, a vending machine. Oh, well, if you're running out of stock in it, it sends a message, oh, hey, we need to go refill this. If you're working with trash cans, I know there's a company in Amsterdam. They're working with trash cans. If the trash can is getting over full, it sends a message and lets them know, hey, we need to go empty this. And then asset tracking. Whether it be you want to monitor where your dog is, or you want to monitor where your shipping containers are, you can absolutely do this. I want to really preface that this technology has many different uses, and for that reason, I think it's very interesting. So I mentioned at the start, I wanted to establish a LoRaWAN gateway. So what is LoRa versus LoRaWAN? LoRa is simple point-to-point communication. So a transmitter and a receiver working in tandem, one transmitting, one receiving, or vice versa. LoRaWAN's a little bit different. LoRaWAN stands for Long Range Wide Area Network, and it's more or less built upon LoRa. So these end nodes could communicate back and forth using just LoRa by itself, and then these end nodes could also communicate to a gateway. These gateways are able to receive messages from hundreds of these different nodes, and once they're received, they're uploaded to the network server. This network server is connected to the internet, and as we all know, the internet's a global system. So that makes LoRaWAN a global system. So if you can connect to one gateway, you can connect to the internet, basically connecting you to the rest of the world. Once this information from maybe an end node makes it to this network server, it can then be uploaded to an application server. These application servers are more or less for data processing or data viewing, and you can view them from, like, say, your cell phone, or set it up to where you can view it from just your laptop or whatever. You can set it up to be wireless, and that's pretty interesting. So I talked about network servers. Well, for this project, I worked with the Things Network. The Things Network is a global open source IoT platform that allows users to set up their own gateways, configure them, monitor them, as well as make use of other people's gateways in the area. So these gateways are, well, user-made typically, and they can either have it set up for a business or just a user, like a regular person. If you're a regular person, you can make use of their free program, where you have to adhere to some, like, what's it called? Some guidelines, but it still allows you to make use of this technology. If you're a company and you want to use more of their resources, you actually have to pay, especially if you go over like a certain amount every single day. But typically these rates are not too costly compared to others, and they work pretty well. So if you just look around, you can see these gateways are all over the world. However, if you zoom in on North America, you may notice a couple holes. One, especially right here in Mississippi. So my project is establishing the very first public The Things Network gateway in Mississippi. And this gateway would connect Mississippi to the internet and technically to the rest of the world. So for this project, my goal, like I just said, was to establish a gateway here at the university, as well as establish the very first public gateway here in Mississippi. So I wanted to bring the technology to the community, as well as the surroundings. Be it you a researcher, be it you a student, be it you just some random guy that's off the street. You can still use it. It's a public gateway. It's a resource just for the area. Alongside the deployment of the gateway, I wanted to configure an end device with the goal of tracking US investments. Now, I could have done many other things, but this is just a proof of concept to show that the nodes work. The node itself would have to, or is wanted, I wanted it to have a range of about 25 kilometers. Now, if you notice from the graph right here, this is kind of lopsided, and it's supposed to represent range. So LoRa works best with line of sight, meaning you can see it from both points. Now, if there's objects in the way, say be buildings in an urban environment, this could really inhibit your range. And that's why I really want to showcase it with this. As you can see around here in the city, much less range, but out over open water, it's much better range, much further range. So the components for this project had the LoRa modules. These are $15 off Amazon. You can make use of them. If you wanted to connect with this gateway, you could buy one of these and set up sensors or set up whatever you want and directly connect to a gateway. I use these for testing as well as learning about the technology itself and learning what configuring the different parameters of it did. After that, I want to talk about the end device. The end device is the LoRa-based GPS tracker. It has a GNSS, which is a global navigation satellite system on it, which takes GPS coordinates at an interval that you can set in the parameters for it. And this device then sends the location to the gateway. And this is the device that I plan to use to track US investments. Not too large, not too small. It can sit on a railing and be out of everyone's way. The project is using an outdoor LoRaWAN gateway mounted on the roof of the Marine Research Center. And as we all, well, for those of you that may not know, it's just down the road up there. It's next to the casino. Now, I want to talk about the components setup. So currently the gateway has been configured and is able to be mounted on the Marine Research Center at any moment. It properly connects to the network. It completely connects to the Things Network, and it's able to receive messages. Alongside this, I've configured this node to be able to send GPS coordinates to the gateway whenever it's set up and it's got power to it. Alongside this, I had to set up the application server once these were all set up. The application server is more or less for data management, meaning you can set it up to view what's going on with your actual system. In my case, I looked through what they have on the Things Network. The Things Network is a bunch of different application servers you can work with. I ended up picking Tag.io, some other common ones, maybe Data Cake or something similar. There's plenty of them. This is not nearly all of them. This is just a simple screenshot. There's plenty of them out there. I ended up deciding on Tag.io, which is a free configurable IoT cloud platform. It allows users to not only monitor monitor their device, but also it logs the data for you. And so it's a user configurable application server while also being a data management server. So in my case, I just have it set up for GPS location, the signal to noise ratio, the receive signal strength indicator, and altitude. But I do want to say, if you wanted to set up another, a different device, you could have it show anything else, be it a temperature reading, be it the level of your battery, how much voltage is being used by it. And next up, I want to talk about my range testing results. So with everything set up, I basically started testing the different ranges for it. I started off very small, right over here in the harbor, right next to the what's called aquarium. Now, this is only a distance of 1 kilometer, but we really wanted to test to make sure everything was working properly. There was no issues or hiccups. And slowly we made our way further and further across, going from 1 kilometer to 5 kilometer, 13 kilometers, 20 kilometers, and 23 kilometers. We ended up stopping at the Golden Nugget Casino. Now, if you notice right here, this is about as far as we can get on land. The reason being is because the altitude difference right down here in Ocean Springs, as well as this island being in the way of the MRC. I mentioned earlier that it works best with line of sight, and so the ability to see, pretty much not being able to see the building or the gateway, really inhibits its range. We went east because if you were to go west, you'd be hitting buildings and other interference, and we weren't able to get more than 5 kilometers worth of range there, and that's why we went this direction. So for the range testing results, so right here I have the different distances, 1, 5, 13, 20, and 23. Now, if you notice, the RSSI value are in the negative, and that's just about where they are. Now, for these, if you notice, the distances of 1 to 5 to 13 are much more varied comparatively to 20 and 23. Now, I do want to preface this and say that for those very first 1, 5, and 13, the gateway was sitting on the roof of the MRC, and I was down on ground level, basically moving across the road and going to different points. But for the last two, these were direct line of sight. I set up inside of 2 parking lots, or 2 parking garages for different casinos. This one right here ended up with negative 108, which is just another 7 kilometers, and it only gained another 4 RSSI value. And then for the 23, it only gained 2. These were very high elevations, for being able to get line of sight I was able to see with binoculars. So this means that at higher altitudes with less interference, you definitely get longer ranges. I didn't hit the 23 kilometers that I wanted to, but I'm sure if I were to get out on a vessel or something similar, or if there was more land going east, I'd definitely be able to reach this distance. The gateway can receive up to a minimum of negative 139 dBm, and if at 23 we're hitting negative 110, that's well within the bounds of this, so we can definitely get more than 25. These are just initial testing results. I wish I could have done more. Wasn't able to, but that's where I'm at. So I want to really go back and talk to you guys about the project and how it progressed. First of all, one of the big questions I was asked is, what would I do different? Now, if you look, this is a Gantt chart. This is supposed to show a timeline of how how you want to actually have your project progress. Now, if you notice, between the plans and the actual, things got pushed really far right. I really want to say, if you're doing projects in design, be wary of your time management. Time flies, and you don't have an infinite amount of it. It really sucks, but it is what it is, and if you do not stick to a very, very strict, timeline, you're not going to get everything you want done. Now, I want to talk about the skills learned and utilized. So for this project, I learned a bit about project management. So with this program, this is the only real time I've actually had a chance to manage my own project. Now, I'm obviously not very good at it, but the idea is to be better at it the next time I do it. These are skills that I've learned to hopefully improve in the future. Now, aside from that, I also want to talk about coding. So for this project, I did do quite a bit of it. Now, there are classes that we teach here, so like MAR 431, which is Marine Instrumentation, CSC1, and CSC2. Those are both C++1 and C++2. I really suggest you do these courses. They are very valuable for your time and also going to be very useful for your future career. And finally, I want to talk about my LoRaWAN configuration. For this project, I really wanted to learn about LoRa, and I can say that I pretty confidently have. I've learned about setting up networks, I've learned about setting up in nodes, I've learned about setting up different configurations, and I'm quite happy with what I've learned about the topic itself. I feel like it's a very useful skill to have in my back pocket, especially for my future as an engineer. Finally, next up, I want to talk about my soft skills. So for communication, I'm not the best presenter, but throughout this program, you're definitely going to get better. It starts off with you just doing some presentations in front of Kamal or Madi, or maybe just Kamal. I know you guys flipped class this year, but as you progress through the program, I can only hope that you get better at communication. It really is just one of those things where you learn and do better the more you do it. Next up, I want to talk about flexibility. So for this project, it started out completely different from where it ended. I wanted to make an environmental monitoring buoy, and I ended up establishing a LoRaWAN gateway. Doesn't really correlate too well, or right off the just viewing it. So the project will change. Things will not go out as what you envision them to be. And so you're going to actually have to adapt and overcome that. Things will not be how you expect them to be always. Finally, there's patience. I wish I had more of this, but I do want to say that not everything is going to go as planned. So if something doesn't work day one, you got to bash your head against that wall. You got to sit there, you got to learn. Maybe it'll come to you after a couple days. Maybe in a couple days' time, you wake up and have a eureka moment, and oh, hey, that makes sense. That's how it's going to be. This project is about a year in the making, so it really is just time. You just have to wait and see what happens and also adapt as you go. Next up, I want to talk about some surprising aspects of the project. So the most surprising aspect for me has definitely been the lack of gateways in North America. So in Europe, they have thousands of these gateways. They are set up all over. They have literal government support for these devices. And in America, they're not being utilized nearly as much. I mean, there are gateways popping up every here and there. I mean, I set up one, and I know another company close by here, DNS, has set up another one. So that's 2 gateways within about a year. They're just popping up, and I expect the technology to more or less take off in the future. Next up, I really have been beating a dead horse on this one, but you really have less time than you think. The second semester will run by. The very first semester, you may not think that, you may think that I'm making plenty of progress. You really aren't. If you think you're making enough progress, you aren't. Plain and simple. So in the future, I hope future students take this into account and really manage their time better than I have. So next up, I want to talk about some conclusions. So what did this project accomplish? I was able to establish the very first public LoRaWAN gateway in Mississippi, as shown right there. I was able to configure an in node capable of tracking at ranges of over 25 kilometers based on the data. Have I had a chance to test this? No, but I would consider it a success based off the parameters that I see. And so for this project, I would consider it a success overall. I was successfully able to establish a LoRaWAN gateway at the University of Southern Mississippi. So next up, I want to say a big thank you to the Eagle Spur program, also known as Eagle Scholars Program for Undergraduate Research, as well as the DCUR, which is the Powell Center for Undergraduate Research. If you're interested in getting funding for like a project similar to this or anything in general, I definitely suggest you guys reach out and do this next semester. It's been a really big beneficial help. Without this funding, I would have been really limited in the scope of this project. I was able to buy this gateway right there, as well as the end node down here. If I didn't have that, I'd be stuck working with these modules, and this project would not be nearly as anything close to what it is right now. Next up, I want to talk about my future plans for this project. So upon graduation, my next step involves continuing my education in the Ocean Engineering Entrepreneurship Pathway Program, also the OEEP program. Now, I want to do this to be able to pursue my MBA, which is Master's in Business Administration. For this project, I need to be able to integrate a business idea, and for this idea, I plan to integrate this project into the program. I'd like to leverage it and really look into building these environmental monitoring buoys in the future. I've learned about the wireless communication, and I feel like as I progress in my career, I could definitely fill out more of these problems and solve more of them and finally get to a point where it's a plausible idea. Next up, I want to talk about the budget. So for the Eagle Spur funding, I received $830. Now, I ended up using roughly 560 of this. I do have another semester, which is a little strange, but I've found out that she doesn't think I'm graduating, and I need to go pick up my stole as well. But whatever. I have about $270 left, and because she gave me that extra semester, I'll be able to hopefully progress the project a bit more and hopefully end up building a more permanent mount for the gateway itself over on the MRC. Aside from that, I want to say a big thank you to all the professors here and everybody here. I'm glad to be a part of this program. Thank you. Are there any questions? I did 20 minutes and 10 seconds. Any questions?
Talk about a value that starts with R.
Received signal strength indicator. It's RSSI. It's more or less it's in units of decibel milliwatts. It's a way to tell the received signal strength for wireless communication, and it's typically used in that.
I have a question.
Go for it.
I might have missed this on your slide. You talked about code. I just wanted to know what do you use it for?
So the coding itself, sorry for interrupting. The coding itself was used for the actual end node itself, as well as for the modules themselves. These devices have many different parameters, such as like spreading factor and such that I didn't get a chance to talk about in this whole spiel. But if you're interested in it, I'm more than happy to direct you to the resources. The Things Network is one of the best resources for actually researching this technology. So if you're interested, hit me up. I'm more than happy to send out the link. Any other questions?
Why are the gateways less popular in the US? Is that just when people aren't turning them up, or they established in the Europe section first? That's just why they're born there.
So the technology originated in Grenoble, France, and I know the technology is been used over there more frequently. I don't know the exact reason for it. I do know they're under different regulations. I know here in America we have dwell time, meaning you can't transmit more than 400 milliseconds at a time before they cut you off. There's also, it has to do with the ISM band, so the industrial, scientific, and medical band. Here in America we use 915, in Europe they use 433, and other countries use different values as well. I don't know the whole details behind it, but I can look into that if you're interested. Any other questions? Go for it.
So, Trevor, you mentioned you configured the LoRaWAN. How time-consuming configuration?
The gateway or the node?
Okay.
So the gateway itself took me about a week, probably because I just had never done it before. I was forced to rely on guides on the internet to try to figure out what I was doing. But the actual configuration itself wasn't as difficult as what I originally thought. It was just, I was doing it wrong starting off. It really is just one of those situations where had I known more about it previously, I would have been able to do better on it or do it faster. It's just one of those things that you have to know what you're doing. It's a little bit of know-how. And in the future, all my stuff will be documented. So if you're interested, I will have documentation of how I did it.
And have you thought about using multiple nodes simultaneously?
Yes. I mean, there's multiple different US investors. You can definitely do it. You can set these up. This was a pre-purchased one. You can definitely do one yourself. It may not be nearly to the same level as this, but I mean, it's a technology that's open source and it's free to use. I mean, if I wanted to set up a temperature sensor for a field 2 kilometers from here, I could definitely do it. If I wanted to set it up to maybe a researcher who wants to monitor the water quality out in the harbor, you can definitely do that.
So you had those small modules, right, which you started out with?
Yes, sir.
And you tested them quite a bit. I think you didn't talk much about that you had no success getting those promised long ranges. Have you found any solution to why those might have been?
So whenever I originally started off using these modules, I had another set. The other set I think I may have damaged. So originally I was using a power supply that may have been over the voltage level, and I think it may have damaged it. Aside from that, it could just be because I was on ground level for both times, and I didn't have like a higher altitude, and I didn't start with like a gateway on a roof. These two nodes may not have been able to communicate effectively due to interference. There's other aspects as well. There's just a lot of things that could have been an issue. I need to get around to testing these new nodes that I purchased and see if I can get further for the final report itself. I can keep you updated as I go.
So you don't know whether you damaged them or not?
No, it's not nothing visible on the damage to them. So if it also happens to these, I'll be able to hopefully start looking into reasons why.
Cool. One question. You said you established these gates. You test them.
Sorry?
If you go to the conclusions, and you say established the first part of the LoRaWAN. It's not established.
I'm sorry?
Is it established now? Just connect to it right now?
At the moment, it's sitting over there on the table, so not at the moment. Whenever it's fully set up, you'll be able to connect to it whenever you want. It'll be 24/7, unless it's like undergoing maintenance or has been taken down for like a safe storm or something. But aside from that, yes, it's open to the public. It's meant to be a public resource. You can use it on your own time.
I have another question. How did you said that here you didn't like track your dog?
So the technology has been used in tracking cattle in the past, or something, or like herds of cow for like farmers and stuff. You can definitely set up a smaller GPS like tag, like maybe like an Apple tag or something similar. It doesn't need to be Apple because it's using LoRa, but you can definitely set up a device similar to that and probably put it on like the collar.
This question is follow up on the Garrow's question. Because those small margins are not really okay, or it seems that they don't have enough range.
So the range for those on the tin says 15 kilometers. In my testing, I never ended up getting 15 kilometers. This could be because I'm in an urban environment and there may be interference. I mentioned before they work best in rural or line of sight conditions. In urban environments, there may be just interference in general that may be inhibiting me. So I think it just depends on the environment.
Thank you.
Well, I have a question.
Go for it.
These gateways be from something.
They need to have a permanent, what's it called, GPS coordinates. They need to be stationary because they're meant to be a resource for the public. I'm not sure if you can make a moving one. I don't think so. I can definitely look into that if you're interested.
Gateway can like stationary, but your nodes can give us like,
Yeah. So the node itself, these, like hundreds of these can connect to one gateway. So if you have gateways all across, say, North America, reasonably you'd be able to connect at any given moment. So say if you want to track your luggage, reasonably you could if you had a tracker. I mean, in Europe, they have thousands of these gateways. Here in America and in Mississippi, there's only 2 of them, because if you count mine.
his goal was to have the gateway more
Could you relay from gateway to gateway? So if I wanted to connect to one in like South Florida, could go from North Mississippi to one Alabama down, or no?
So as long as you can connect to one gateway, you can connect to the internet. So technically speaking, you could. But I mean, if you can connect to one, you're already connected to the internet anyway, so there's no need.
Okay.
So say if you're moving from South Florida and you're moving over here to Mississippi, as long as there's a gateway in range, you could still connect to your setup. It's a global system.
Well, if you're using one instead of as a gateway, could you use it as like a repeater essentially?
What do you mean?
Connected to internet. So like say if I needed to do something that was out of range of to the gateway, without a gateway being connected to the internet, would you got to use it to essentially relay the signal from the node to the next gateway or node, whatever, to the next one?
So as long as it's in range, you can connect to it. And whenever a node tries to connect to a gateway, it sends out a signal to all gateways in the area. Whichever one it can connect to, it decides, oh, hey, this is the one you wanted to connect to. But as long as it can connect to one, you're connected to the internet. I'm a little bit confused in your question. I can talk to you afterwards.
Connected to the internet with the gateway. That's what I'm saying. Like if you just had that connected to power, could you communicate from node to
Node to node?
and then from that node to another node to relay the signal?
Yes, it's point to point, so going from one to another to another. I'm not sure, I mean, these modules themselves, you actually have to configure to connect to one or the other. You actually have to put in like a network ID, you have to put in like a ID for that. So I suppose if you had it at an interval in which it changed codes around, so like a loop that every like, I don't know, 10 hours it changed, you could definitely probably set it up to do that.
But there's a difference between LoRa and LoRaWAN.
Yes.
LoRaWAN relies on those gateways to be connected to the internet. But the nodes themselves, they can build networks without relying on LoRaWAN.
Yeah.
So that's fantastic, I believe. As long as one node can talk to the next, they all can connect to each other. Just rely on any infrastructure.
I know some aquaculture farms are using that, and that's where I found out that technology. I was reading a research article about how they were using it on unmanned service vehicles for an aquaculture farm.
You probably can because the bandwidth is really
Money speed up, you don't have to text
but I don't think that we can use it for the current repeater because bandwidth is really limited. We cannot send it.
Oh, no,
I mean, like a sensor reading, yes.
well, talking about
Yeah.
Yeah, you can just use nodes.
No, I mean, if you want to send data, you think that like an internet device, you move data around, I don't think that you still can have like network sense from like temperature information from here to there, but you cannot transfer much of the information.
yeah, that's all I was talking about. Communicating from one node to another and then not communicating with the next.
It will not want two little things can happen.
Yeah. These two right here can connect directly to each other, point to point. Are there any other questions, or?
So
Okay. Other one?